Lab Guy here. This is just a quick update to let you know what's going on. I've completed reassembling the drive amplifiers on the Dissector Cam Board and have proceeded to test them. Unfortunately, there's no change to report there. It's working exactly the same. We may have reached the actual limits of the dissector tube that I have. One of the factors that determines resolution in a dissector tube is what's called the aperture size. The aperture is the pinhole that allows electrons into the multiplier section right behind the scanning section. And that pinhole can vary in size based on what the customer ordered. I have 3 of these tubes, and the one I'm using right now is the one that gives the highest resolution. However, it's right at its limits at 32 lines. I believe that these tubes were used as weapons aiming devices in military applications. You're all familiar with the laser designator type missiles where a field soldier puts a laser dot on the desired target. The missile is launched from some distance away and homes in on that laser dot. I believe this is the type of sensor that was used in the early designs of those devices. I could be completely wrong. I have seen application notes where these tubes were also used to study the speckle pattern of laser beams and to track the white dot of light on eyeballs for eye tracking systems. Okay. So the dissector tube lends itself to certain spot tracking applications versus a standard TV camera, which you need to put the video into a frame buffer and then find your spot and track it, which is intensely software intensive, is what I want to say. On other news, the job hunting is going very well. I have a hot prospect that looks like is materializing into a job, and it's about time I get off my lazy rump and get back to work. And so hopefully that won't impact the frequency of these programs in the future. I'll just have to shoot them on the weekends or in the evenings. I'll lose the luxury of having the weekday at my disposal for the most part. So let's take a quick look at the Dissector Cam Board, and I'll point out the general changes versus the old version, and talk about the results at that instant. The original amplifiers were located right here. They were these little tiny voltage follower chips, LH0002, made by National Semiconductor in the 1970s or early 80s. They're very nice chips, wide bandwidth, 200 milliamps of drive current, bipolar capable. I replaced them with a standard totem pole arrangement as shown in this schematic here. And there's 2 of those, and each one has a single op amp assigned in this package, which is 4 op amps. 2 are devoted to the amplifiers, and the 2 others are devoted to the ramp generators. We have the current set transistor here and a current set transistor here, which gives us constant current for charging our ramp capacitors, which is here, the yellow one, and the little blue electrolytic. And the other 2 transistors are 2N7000 field effect transistors, which short out the capacitors and restart the ramp, either each line or each frame. This side is the line side, and this is the frame side. and the drive pulses for those come from my classic sync generator. The deflection yoke is connected here, X and Y, and the power supply enters here on a convenient connector, which allows me to rapidly remove the board and make changes and tests. So that pretty much sums up the progress of the board itself. The remaining issue to correct in the camera is the back focus problem with the lens, but I'm working on that as well. The attempt to fix that, as I mentioned in the previous video, had failed. And so instead of a thicker lens mounting housing, I'll print out a thinner lens mounting housing, and we'll determine how that goes. So the next phase of the circuit design is to move the video amplifier from the external breadboard onto the main board and add the sync combining circuitry so that the camera will actually produce a standard NBTV output signal that is a composite video signal with sync pulses and picture information, which we can then send to the little CRT televisor and see the picture from the camera on the little tube and see how well that works out. Progress is slow but steady, so hopefully soon we will have the televisor with the CRT, the mechanical televisor, and a matching camera that can produce at least some sort of an image. Whether it has to be a Maltese cross or possibly we'll be able to make out Felix's face much better. Felix is ideal because he is simply black and white. I have tried it with Spud, but as you can see, Spud has colors, and converting colors to grayscales may or may not work depending on the camera tube. He seems to look okay on the oscilloscope, what little I can see so far. I think we'll see more when I fix the lens. And also, when I move the video amplifier over, I will add a gamma correcting circuit, and we will introduce gamma correction, because I believe that these camera tubes are exceptionally linear and they don't look good on cathode ray tubes. So we will have to introduce the gamma correction to compensate for the cathode ray tube display. I'm not sure if how that will affect the mechanical televisor, which has a linear light display. So I may have to make it switchable in and out, and I may just leave it completely adjustable. There's a circuit I like that does a very good job of gamma correction, and it has a full range of variable resistor that when it's centered, the amplifier is linear, and when you turn it in one direction you get negative gamma correction, and in the other you get a positive gamma correction on the transfer curve. And this should allow us to compensate for any type of display that we use. So it should be very interesting to see that in operation as well. So the only downside to that circuit is that the integrated circuit used in it is becoming harder to find and is nearly $20. It's a quad current amplifier, quad current op-amp amplifier. And I forget the manufacturer, but they are available on DigiKey, and like I said, they're nearly $20 now. As the stock decreases, DigiKey likes to raise the price, which who can blame them? All right, so that sums up where we're at. I will probably be going back to work this coming Monday if I'm extremely lucky. Let's knock on wood. I had that piece of plywood implanted surgically, elective surgery, and just for this purpose. So until next time, this is Lab Guy out.